Here we are with the new cell, or not new cell, new container, with the cell in it. The main reasons I've got this container is it seals so much better than this other container. I've also got larger wires than the other one. The other wires I was using were quite thin, so this one, and these wires do not heat up as much, so it's not going to be wasting heat energy in the electrolysis process. So that's quite that's a important thing when you're doing electrolysis. Make sure you've got quality wires, so you're not wasting any energy. All the energy that you electric energy is going straight into your cell. Now, what I want to start off with is talk about what the electrolysis and HHO can do for you. HHO, you can actually run your car on it. So with the along with petrol. So you just inject it into your airstream, and you can hopefully increase your mileage. Another thing, this electrolyte, during the electrolysis process, chromium-6 leaks out of the stainless steel plates. So don't throw that down the sink, down the toilet, whatever you want to do with it. Put it in a container. I've got mine in a container labelled waste electrolyte and chromium-6. So you should probably do that as well. And then you can take it to a hazardous material disposal point in your local council. Alright, this cell, as I said in the last video, is an experimental cell. I'm going to do some tests on it to see what best plate design will work for me. I encourage you to do the same. Do your own experiments, see what works for you. So the next cell that I will put in this, I will have all the sheets professionally cut and to the exact same size. So, and I'll make sure that it will fit into the container. Alright, what I've been working on. I have been collecting HHO gas. I collected it in a 2 litre milk container, and then lit the container with a sparkler as a fuse. So it's not all that safe, but it gives you an idea of the actual potential and the how much energy is in the hydrogen and oxygen gas. Also, I've got this container here. I'm measuring how much is actually coming out of this container. So when I fill this with water. Right to the top. Now I know this container holds exactly 600 millilitres when it is about here. So then turn on my power supply, wait for the gas to come through, and as you can see, gas is coming through there. Now put it into this bucket. With it completely full, turn it over, start my stopwatch. And as you can see, this is the water level is dropping slowly. Now I'm not going to continue doing that because my power supply is hitting up quite a bit. It's drawing 8 amps, and the probably recommended for this particular power supply is only about 6 amps, 7 amps max. So this is heating up quite a bit. It's getting a bit warm to the touch. So that's another thing, you need to get a quality power supply if you want to make a reasonable amount of HHO and do some decent testing. So yeah, I did this test before, and I got about calculated to about 2.18 milliliters per minute per watt, which is actually not all that good for not that good efficiency. So I'm going to need to seal off the edge of the plates of each plate. I'm going to grind down or clean up the plate surface area and run some more tests and see what happens. Also, one other thing I'd like to mention is my website is explosivelabs.org. Go have a look at it. That'll have all my cell designs on there and all the up-to-date information on any of these experiments. Righto. Here we are with the cell and the container, the cell out of the container. Here is the top of the lid. As you can see, I've got one clip, which this is the negative. This negative lead goes to the middle one, like so. That's just clipped onto or crimped onto a washer, and same with this one. The positive leads, they go onto the outside terminals. Right, when you're doing your HHO generation, as the solution heats up, the electrolyte heats up, your cell will want to draw more amps. That's the reason why my power supply is pulling more amps. Now, also another influence of the current is the spacing between your electrodes. So if I put positives on the outside and negative in the center there, it will draw a certain amount of current. Then if I change the spacing of the electrodes and put them, say, on these two, so there's only two neutral plates, it will draw a lot more amps. I don't exactly know the ratio of that, but it will draw more amps the closer you get the least amount of neutral plates you have.